So the next problem we are going to discuss from the Stybus SD sheet is the problem from the day 3, that is the last problem from day 3, the reverse pairs. So what the question states, that we are given an array nums, return the number of reverse pairs in the array. So what are the conditions for the reverse pair? A reverse pair is a pair for the value of I and j, where I and j lies in the range from 0 to nums length, मतलब array की length, and nums of I is greater than twice of nums of j. So basically जो हमारी कंडीशन गिवन है, क्या गिवन है कि हमें एक नम्स एरे गिवन है, ओके, नम्स एरे गिवन है, उसमें हमारे पास आई और जे, हमें रिवर्स पेयर फाइंड करने हैं, नंबर ऑफ रिवर्स पेयर फाइंड करने हैं, जिसमें क्या होता है, जो आई और जे हैं वो हैं, और वो लाई कर रहे हैं इन द रेंज 0 से नम्स की लेंथ तक, ओके, जो एरे की लेंथ है वहां तक, ठीक है, और सेटिस्फाई कर रहे हैं एक कंडीशन कि जो तुम्हारे आई इंडेक्स पे एलिमेंट है वो बड़ा है ट्वाइस द एलिमेंट दैट इज प्रेजेंट इन द jth index. Okay, so this is the basic possibility. We have to find such pairs, how many pairs that exist in the nums array. So हम यहाँ पे एक एग्जाम्पल कॉपी कर लेते हैं. Okay, so for the particular case इंडेक्सिंग कर लेते हैं इनकी. ओके, तो हमें ये एरे गिवन है, हमें रिवर्स पेयर फाइंड करने हैं, जो कि जहां पे तेरे दो इंडेक्स है आई और जे, सच दैट आई जो है वो क्या है, आई जो है वो छोटा है जे से, आई जो है वो छोटा है जे से, और नम्स ऑफ आई बड़ा है ट्वाइस ऑफ नम्स ऑफ जे. सो we'll find the particular condition. So suppose our I is this, that is index 0, and j is this. So is the condition satisfying? No, because nums of I is 1, nums of j is 3. So अगर हम उसका twice करेंगे तो 1 is not greater than 6. So this condition remains false. Okay, the next possibility, let's suppose our I is this one and j is this one. Okay, then the possibility is 3 is greater than 2. So this is one of the case that we have found the reverse pairs. The same for this one, we have found one more pair. So these are the two possible pairs that can be found in this array. So from a particular array we have to return the possible number of reverse pairs that can be found in an array. So we can easily solve this in order of n square approach. We can use two loops to iterate over the array for a particular element. We can check to its right, to the rightmost element from the particular element. Let's suppose we are present in this. So from this element to the last of the array, we'll check every element if it satisfies the following condition. So this remains I, and our j will loop over to I plus 1 to the length of the array. We loop from I plus 1 to the length of the array and find the condition where nums of I is uh, greater than twice of nums of j, and we'll found these possible number of pairs. Okay, so this approach require order of n squared. So can we optimize it? Yes, we can optimize it. So how can we optimize our approach? Because our current approach is taking order of n square of time. So what's the best possible approach we can apply? What we can do, let me take a simple array, simple test case array, 1 3 2 3 1 with their index 0 1 2 3 4. We have to use the merge sort. This is the basic pattern when we have to find, when we have given the condition like I is greater than j, and we have to find the number of pairs where AR of I is greater than AR of j, or something like that. This is the basic pattern where we have to apply the merge sort to get our answer. Okay, so what we'll do, we'll apply merge sort, we'll divide it into two part based on the middle element. We'll have 3 and 1 with index 3 and 4. We'll further divide it with the middle index, because the middle index is 2. We have got 1 3, and here we get 2, and here we get 3 and 1. 3 index, 4th index. Here what we get, we'll further divide it till we get 1 1 element. 1 1 element, because one element is itself sorted. So here is, so we have applied the merge sort. We have divided our array based on the middle element into subarray such that till we find one element array, one element subarray, and we know that a single element is always sorted. We find a single element. So what we have to do for these two subarrays, what we have to do, we have to check for this subarray element and this subarray element. We'll check. Let's suppose for this subarray we'll take the index I, and for this subarray we'll take the index j, and we'll check if ARR of I is greater than twice of ARR of j, and check if the condition satisfy. We're gonna increase our count by n minus I, because if, let's suppose we have got three elements such that 3 and 5, and here we have got 1, and we are checking for the condition I j. If ARR of I is greater than twice of ARR of j, 3 is greater than 2, this is the basic condition. So if they are arranged in a sorted order, because what we have to do now, after we have found the element in this left hand side subarray such that ARR of I is greater than twice of ARR of j, will increase our count by n minus I, where n is the size of this subarray and I is the current index that we are taking into count. Okay, and so for the present case, is 1 greater than 6? So it is not possible. So what we'll do, we'll sort the array. We'll merge the element, the sorted manner, that we'll get 1 3, what, 3 1 0 1 2 3, and then we'll take these two subarrays into and check the following condition. If ARR of I is greater than ARR of J, twice of ARR of J. If the condition don't satisfy, we move to the next element. If ARR of I is greater than twice of ARR of J, if 3 is greater than 4, because 2 into 2 is equals to 4, then if the condition does not satisfy, we move to the next element. If the subarray ends, we're gonna merge the two subarrays. We're gonna merge the two subarrays. We're gonna merge the two subarrays and then compare it with further subarrays. We'll take these subarrays into count, 3 1 3 4. We'll check I and J. If ARR of I is greater than twice of ARR of J, yes, condition has satisfied. We have increased our count. Count plus is equals to n minus I, where n is 1 and our correct index is 0. Our current index is 0 for this subarray. Na? For the current subarray, our index is 0. So our count will become 1. Okay, then we'll merge these two subarrays in the sorted manner. What we'll get 1 and 3. Then we'll compare these two subarrays. 1 3 2 and 1 3. And what we'll check, we'll check for I and J. If ARR of I is greater than twice of ARR of J, if the condition do not satisfy, we move to the next element. If ARR of I is greater than twice of ARR of J, we'll increase our count. We have found one more element. So this is 2, this is 3, because we have to merge them in sorted manner. So we'll check for 2. If 2 is greater than 2, if it is not the condition, we move to the next element. If 3 is greater than 1, 3 is greater than 2, yes. So we'll increase our count. Count plus is equals to n is 3 minus current index is 2. So our answer will become count plus is equals to 1, and our count become 2. And we'll increase, what we'll increase, I remains the same, we'll increase the J and check if ARR of I is greater than twice of ARR of J. 3 greater than 6, no, it is not the case. We'll increase J, we'll increase I. Now the index I have become equals to 3, that is out of index. So if I become out of index, what we'll do, we'll merge them in the sorted manner. We'll merge them in a sorted manner. Then we have got the whole array sorted. We have found our count equals to. So this is how we'll solve the reverse pair question. हम कोड देख लेते हैं अब इसका. So what we'll have, This is the main function that we are given, that is, we are just given the vector nums. So what we have done is use the merge sort function. In merge sort function, we have passed the starting index, the ending index, the array, and the count of the reverse pairs that is initially 0. We'll check for the base condition and apply the merge sort till we have found a single element, because single element is itself sorted. We have used the merge condition, and we have checked if L of I is greater than twice of R of J. We have increased our count by n, count plus is equals to n minus I. So that's the condition. We have increased our J, else we have increased our I, and after that we have merged these subarrays in the sorted manner. Okay, so this is the whole code. We'll run the code, try to submit it. It's submitted successfully. So this question is basically the extension of the question which we have discussed previously, the inversion of array. If you have understand the question inversion of array, then this question is basically just a simple extension of this question. Okay, so if you have any doubt, you can ask. Bye.